Alright, I think we are live. I would say let's do another session of TypeScript Type Challenges. Next one up is read-only. So, implement the built-in read-only t-generic without using it. Constructs a type with all properties of t set to read-only, meaning the properties of the constructed type cannot be reassigned. We also have an example. Let's open that up in the code editor. I have it here. Like always, first I'm gonna create a test type that is using our created type. We have an interface to do one to test it, and right now this returns any as expected. Okay, so we want to create to do one entirely as read only. Alrighty, then the easiest thing is again a map type. So we're gonna loop through all keys in key of t, and if we now put t of, like if we index into t with key, then we get the normal object, so test should be equal to to do one. Now to make it read only, we can just add here the read only modifier if we spell it correctly, and that should be it. Now test is everything read only, and watch out, it's not deeply modifying it. So let's check out other solutions. The one test case passes. Let's see. First one is English, has a lot of likes, sounds good. Okay. This person does read only, then a map type. So that's exactly what we did. Alrighty, let's do a quick recap of this. So, what we did is we constructed a map type, added the map type modifier. Let me look up the exact name. TypeScript docs modifier object. Documentation map types. Mapping modifiers, that's the right name here. Read only and question mark, so basically read only and optionality. So let's recap that. We have here a map type with a mapping modifier read only, and then we just loop through every key in the object and make the key read only. And what's interesting about this is that it's not deep, so basically just the first level gets casted to read only. The second level, as you can see here with author string, stays mutable. Alright. Next one, I would say. We have here the next one. It's called easy tuple to object. Let's check it out. Given an array, transform it into an object type, and the key value must be in the provided array. Okay. So we're given a tuple as const, so the tuple basically is not just a tuple of strings, so it's a tuple of exact values. And we want type result tuple to object type of tuple. Expected Tesla Tesla model 3. Okay, so basically every value is used as key and value. Alright, let's start with that. I quickly have to toggle night shift so everything stays fresh. Again, first we're gonna do the test type. Tuple to object, and we can run this on tuple. Type of tuple. So right now we get any, as always. So the first thing is that we can do is restrict this tuple so it can only extend property keys. Property key is a built-in union of, as you can see here, string, number, or symbol. That's basically everything that can be used as a key in an object. So now we know everything that T contains will be usable as a key, and we can then, let me think for a second. Do we need to use, can we use a map type? Let's explore this. So key and key of T, which does make sense because it's a tuple, but whatever, we are gonna entertain this. So what do we get now? We get read-only tuple. Okay, that didn't do a lot. Alrighty, what else can we do? We could loop through it, but there's probably a simpler thing. So what I mean by looping through it is we can loop through a union by saying, okay, T of number, because it's an array, extends unknown. No, wait, T of number is already the union of all possible values in the tuple. How do we get this into an object? Basically, I mean T number to T number, I would say. Property or signature expected. We can just do it here. Let's try this again. Key in T number. Alright, let's take a look. Oh, okay, we have now Tesla is all of the values. That's not what we want. Basically, we have now here this correct thing, but over here we still have the union, which we don't want. So we want to have here the exact value, which should be key, which is not correct. Because we cannot use, okay, key is gonna be a string and we cannot use a string to index an array. So how do we get here? So basically we want here T of 0, for example, for Tesla. Tesla is now correct, T of 1, and so on. I'm thinking, how do we do that now? T of number is again the entire union. No, we can just put here key. Stupid me, but obviously key, we already have in key the correct string that we want, then it's just very easy to put it here as a key. Alright, let's check out the tests. We have a lot of tests, but they all seem to pass. Here this one expects an error and also throws an error, so that is correct, I guess. Everything is the way it's supposed to be. We get here the right object. Then I would say let's take a look at the solutions. First one in English. Okay. So, given type tuple to object t extend read only any array equals any. First of all, we need to get rid of any array. Input array is read only and has only strings at values, so we can use read only string array. Okay, then we should transform array literal type to object type. Map types to the rescue, yeah, that's what we used. We can iterate every value in array within map type using in keyword. T extends read-only string array. I guess this is a bit older because we also accept here numbers and symbols. So this is definitely better to use. Oh, here, okay. Now arrays not only include string but also numeric types. All right. Here we have, yeah, there's the built-in property key. Perfect. So basically, this is exactly our solution. Let's recap. So we start with this. Let's do this again step by step. So we start with this. We have our test type, which leads to any. First of all, we're gonna constrain the tuple that we pass in not to any array, but to property key array, which is a built-in type that's a union of string, number, and symbol, so everything that can be used as a property key for an object. And then we create a map type and say, all right, we want all the keys in T of number, which has the function T of number basically destructures the entire tuple as a union. So all of the values in the tuple get returned as a union, and key loops through this union. And then we just need to put key here because we already have the exact value that we want. So that's why we can do that. We want key and value to be the same. That's why we can reuse the key here. Easy. Next one. Let's check it out. First of array. Implement a generic first that takes an array T and returns the first element's type. For example, array 1, strings ABC, array 2, 3 to 1, head 1. First of array 1 is expected to be A. Okay, so it's narrowed, it's not string. First array 2 is expected to be 3. Alright, let's check this out. First of all, we're gonna do type test equals first of. Do we have any array? Not really. We're gonna put this in. Oh no, let's do the string array. A, B, should be enough. Alright. So this, as always, gives us any. So we want the exact type of the first object. Let me think for a second. So we want the first type. We can always do infer first. Infer rest is only okay if the tuple extends infer first, infer rest, then first, sonst never. Okay, let's make this a bit prettier. It doesn't do that automatically. Okay. That's better. So where do the dots go? I always forget that. Oh, like that. All right. So rest is declared, but its value is never read. We don't care. So all right, let's look at this. The test gives us A. Looks good to me. Let's try it with numbers. It gives us 1. Perfect. So what we did here is we accept any array, then we check, okay, is the array of this type, like does it have a first element and rest? If yes, then return the first element. If not, then never. So we get the, if we pass in an empty array, we will get type never, which makes sense. We don't have a first element. If we put in only one element, we will get the first element, because rest can be empty. The underscore tells TypeScript that we are not going to access this variable and it's just a placeholder. So all tests are running. The errors throw errors. And I would say we're going to check out its solution and then we walk through it again. First of array, is that now English or Chinese? Let's check it out. Okay. So here we check answer 1. Check if t extends an empty array. If yes, then return never, otherwise return the first element. Smart. That's also what we kind of did. This is exactly our solution. Infer A, infer rest, A never. And then we also have here t length extends 0. Okay, you can check the property length on the array, and if that is 0, then return never, otherwise return the first element. Nice, cool solutions. I would say we are gonna run through it quickly again to make sure we got that. So let's do multiple options. First, we're gonna check t extends an empty array. If that's the case, then never, because there is no first element, otherwise return t0, the first element. Then second solution, I'm gonna copy this. Second solution is t extends an array of the type infer first, infer rest. If that is the case, we're gonna return, we can return first, otherwise never, because otherwise we will not have a first element. That's the second solution. And the third solution is basically checking the length property of t, and if that extends 0, then it's an empty array, so we don't have a first element. Otherwise, we can return the first element. Awesome. No, let's leave that solution in our code. Okay, next one. Let's check it out on GitHub. Length of tuple. For a given tuple, you need to create a generic length. Pick the length of the tuple. Okay, we have just arrays with however many items in them. I would say we don't even need a test, it's really easy. So we just learned how we can get to that. So of t length, we just return that. First we have to constrain t to any array though. Okay, that doesn't work. Let's check out the error. Okay, we do need a test type. Type test equals length of type of Tesla. So read only, type read only blah 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 does not satisfy the constraint of any array. The type blah is read-only and cannot be assigned to the mutable any. Ah, okay. We just have here a mutability problem. So if we put in here read-only array, then everything is gonna be fine. Okay. I don't know how this works though. Let's think this through. So we cannot assign an immutable array to a we cannot assign a read-only array to a generic that expects a mutable array because the generic might mutate the array. That's why we need to constrain it to read-only here. So basically we are telling TypeScript here, okay, length is not going to mutate our array. We can also now put in, I'm going to do it, we can also now put in tuples that are not read-only. But it doesn't do what we want because sconst prevents type widening. So that actual type is exactly these values and length counts the different values. Is that true? I don't know. Okay, here test2 is 5. Length type of space x. Ah, test is number. Can I return that as const? No. Okay, due to type widening, we get here number instead of 5, but we want the exact number. Okay, interesting. Alrighty, but we got it. Let's check out the solutions after checking out the tests. Okay, works perfectly. Oh, solutions. English. Type length, t extends read only any array, t length. Okay, that's easy. Easy. Okay, let's think this through though. What was the start again? Length of tuple here. So we started with, I think this, and it was any. Alrighty, let's think about it again. Type test equals length of type of Tesla. So should be any, is any. So to get the length of a tuple, we can just do t of length. So now we are accessing the property length on the tuple of t. Since we now need to constrain t to an array, otherwise that doesn't make sense, because the length property only exists on an array. Now we have the problem that we are trying to pass a read-only array or tuple to a generic that is expecting a mutable array. That means we're basically not guaranteeing that length does not mutate our array or our tuple. That's why we have to put here a read-only. Then we get here the perfect number, which is 4. For space x, it's 5. And it does not work with normal arrays that are not constrained with sconst because space y just returns number, because here we have a case of type widening So the type of this, we can also see it, is just string array. Space X is literally this array, string array, and we do not know the length of a string array because it can be a string array with 1, it can be a string array with 100 elements, so it's variable. It can vary, that's why you have to put here as const and then it works as expected. Alright. Easy exclude. Let's check this out. Next one. Implement the built-in exclude TU. Exclude from T those types that are assignable to U. For example, my exclude ABC A equals BC. So you are kicking out of the first union everything that is in the second union. Everything that is assignable to the second union. Alright. Let's think about it. We have to check. So T to distribute over a union. Distributing over a union, by the way, means to look at each part of the union step by step. So first A, then B, then C. To distribute over a union, you just write T extends unknown. Unknown, which is always true because unknown is the ultimate supertype, so every type extends unknown. True. I'm not so good with formatting here. True or false. So test type test equals my exclude A, B, C, and we wanna, didn't do a union here. A, B, C, we wanna first kick out A. That's enough. So this should be true. It is true because T extends unknown. If we now return T here, we get just the entire union back. So now we have to check does T, so the important difference here is T extends unknown. I'm gonna explain it later. T extends now U, and if that is the case, we return never because we want to kick it out. And if that is not the case, we're gonna keep T. So this should be now BC. Okay, that was easy, and I'm gonna explain it in a second more. Let's first check the test cases. They all look good. First, let's look at a solution. Answer. Don't know if that's English. Yeah, my exclude TU. T extends U. Never T. Okay. It's a union. Apparent. Can I? That's interesting. I thought we have to distribute over the union. Distribute over union. Maybe I should put in TypeScript. Okay, with distribution, the operation is not performed on just the common properties. Instead, it is done on every member of the union separately. The results are then added together. Okay, species, curvature, color, blah, blah, blah. Okay, I get that. In this case, TypeScript applied key off to each member of the union and summed the results. Okay. The term distributive refers to how union types should be treated when subjected to type-level operations such as key, off, or map types. Let's check this out. So, apparently we can immediately compare two unions. A, B. No, wait. I'm gonna do T extends U. If yes, then T, otherwise never. So, this is A. Ah, that's exactly the opposite. Sorry about that. So, BC. How does this work though? I want to understand it internally. So, I'm gonna make a copy, my exclude 2, to understand this better, and we're gonna just write here A to understand if it distributes. B, C extends A. That is ABC. Ah, because it returns T. I'm gonna just put true, false. So this doesn't extend. Right? Yeah, but that has to be automatic, otherwise it doesn't make sense. So we get here now a false. But I'm gonna put here now X. It's gonna be X, which makes sense. So TypeScript distribution union. Distribution, distribute, not in here. Reference. Handbook. Type manipulation. Conditional types, yeah, that sounds good. Ah, here, distributive conditional types. When conditional types act on a generic type, they become distributive when given a union type. For example, take the following. Type extends any if we plug a union type into array. Now I get it. It is distributive as long as it's not wrapped in a data structure. So like this, it would not work. So let's say here, T extends, which also makes sense. My exclude ABC. Okay, but let's get back to it. If we plug a union type into toArray, then the conditional type will be applied to each member of that union. Makes sense. So, toArray. What happens here is that toArray distributes on string number and maps over each member member type of the union to what is effectively to array string to array number, which leaves us string array number array. Typically, distributivity is the desired behavior. To avoid that behavior, you can surround each side of the extends keyword with square brackets. Exactly, that's how you prevent distributivity. Alright, okay, let's walk through this again from the beginning. Great. Learned again something new. T extends U, never T. So, what we have here, we get two union types. And the solution is just T extends U. If yes, then never, because we want to exclude it, and otherwise T. This works because this distributes over the union, so each part of the union is handled separately. So first checks, does A extend U, which it does, then never. Then does B extend U, which it doesn't, return B. Does C extend U, which is it doesn't, return C, and so on. So this is how this works. Plus, returning never with a union gives you always just the union. So type, I'm gonna call it a normal union, is A, B, C, and then we have type never union is a normal union or never, which then is normal union. See, never just gets cut out of a union. Alrighty, easy awaited. Oha, getting into promised land. The promised land. Alright. I would say it's the last one for today. If we have a type which is a wrapped type like promise, how can we get the type which is inside the wrap type? For example, if we have a promise example type, how to get example type? Type example type equals promise string, result my awaited example type string. Okay. First we're gonna do a test. My awaited of t equals oh no, not equals anything. That is any. Perfect. So I have to think about that. X. But it looks like t number. So it looks like it's always a promise. This is supposed to be number unfulfilled. Pooh. I would say t extends promise. Unknown. Then, oh no, let's say here infer value, return value, otherwise never. Okay, my awaited t is never. Makes sense, I just put t in, it doesn't make sense at all, so put in x, that is string. Okay, so it works for some cases. Y, field number, okay, that looks good. Promise, otherwise we just do this again. My awaited of t. Does that make sense? No, it doesn't make sense. Okay, let's check this out. This is where does it not work? Here with z. let's check this out. What do we get? Promise, string, or number, because it's a promise inside a promise. Cool. So we have to go recursively. Alright, if we go recursively, then let's think about it. So basically what we have to do is to go recursively, we call this again, like my awaited again, in this branch, otherwise we can't accept the inferred value, and we return the value if it doesn't fit. That also doesn't make sense. Then we return t. Okay, so now we have a deep check for promises, so z1 should also be the right value. String boolean. Yeah, how this works is t some kind of promise? If yes, alright, then put the value inside the promise into this function, and this goes on and on and on until it's not a promise anymore, then it returns the type of the value. So that's easy, but false does not satisfy the constraint of true. Thank you for that. So with t, let's check out what do we get. Probably then unfulfilled arg number. How are we supposed to get that? That doesn't make sense. So this is an object. I have to say, my weighted number. This is supposed to be an error. Okay. Even though it should be, in my opinion, it should be number. Whatever, okay, this has to, extend a promise of unknown. Missing a square bracket. No, what's this thing called? I don't know. Type val does not satisfy the constraint promise unknown. Okay. Catch finally. Okay, let's check out what the promise type even is. So it's an interface which has a then. So it can be also partial promise, because it's enough if there's a then. My awaited promise attaches callbacks for the resolution, blah, the callback execution is resolved on rejected. Okay. Promise like awaited. Oh, here. Recursively unwraps the awaited type of a type. Okay, this is probably the solution, but let's not look at it too much. So this can be a partial promise of unknown. As partial promise. No, that doesn't make sense. Okay, I'm gonna now build a helper. Type as is. Here we're gonna check it's a generic. And we're gonna check if something that we pass in equals something else. So t equals u. So if t extends u, then we return t, otherwise never. So with this we can check here if the value is some kind of promise. Am I missing again? Yeah, missing one again. Then we can kind of force it to be, so we are saying, okay, we're just passing something in if it's a promise. We can even here make partial promise. So now we are enforcing that we definitely have a partial promise, otherwise we're not calling this. So this t does not satisfy the constraint partial promise. Types of property then are incompatible. Unfulfilled arg number any is not assignable to unfulfilled value unknown are incompatible. Type undefined is not assignable to type. Because do I have to take out the partial? Okay, let's wait with the partial a little bit. No, still not working. Alrighty. This is a hard one. I would say we're keeping it for the next time. Okay, wait, partial. No, I have to get this now. Partial. Only if this is a partial. We're gonna continue. False does not satisfy true. Oh, I broke it. So if you put in x, what do we get here? Never? Shit. Because that doesn't make sense. This does not make sense at all. I don't know why I did that. My awaited of val. Like this. Okay, now everything works. Except for this. Partial promise here. Okay, wait. So this now apparently works. Type tests of t is number. Nice. Then oh no. The only thing where we're saying this has to be something is that number my awaited number expects an error. Okay, this extends a promise. No, then everything else fails. I don't know. Let's look at a solution. I think we are close enough. Okay, we have here a complex thing where this then function is handled separately, which I don't like. Okay, my type my awaited t extends thenable any or promise any t extends promise infer inner. Okay, I get that. Inner extends promise any. Okay, if that's another promise, then you await again. Okay, I get that. This extra loop makes sense, and then would also catch an error. Otherwise, you return inner. T extends thenable. Okay, no. The goal is to get the value wrapped to the promise. Why all this when you can just, in a simple line, my awaited t extends promise like infer u, my awaited u, t. I mean, that's basically what we have. Your type does not cause this to error. This adjustment works. My awaited t extends promise like any, or promise like any. No, that's also not what we like. So this is either a promise like of any or a promise like of a promise like of any. Why? T extends promise like infer v, v extends promise like any. Okay, I get that. Because he has to do it so he can check it here. And then throw a otherwise, that's the check with the number, I guess. Yeah. Yeah, that's all not the most amazing thing. Okay, let's check this out. Your code here, thenable again. No, we're not doing thenable. Let's check out promise like. I think the cleanest solution is this extra round to check, okay, is no, wait, is that even enough? Okay, this extra round, let's think about it. Extra check here. So we only do this recursive step if val extends promise of unknown. Otherwise, never. No, now everything is wrong again. Great. I think I switched them around. T, never. Still wrong. Okay, T extends partial promise, infer val. Okay. If this is something close to a promise, then check if value is also a promise, of anything, but this can also has to be a partial promise. Then run this function again. If this is not a partial promise, then return t, which is the type, and if it is not a promise at all, return never. Seems reasonable to me. Okay, let's start here with x again. What do we get on x? Promise string. T extends partial promise. Maybe I have to return here value. Yes, but it's still not an error. No error. Okay, then first let's check out promise like. Okay, promise like is basically the same except for the catch, so we don't have to do partial promise, we can do promise like. That makes everything a bit more concise. Partial promise, great. Then let's kick this second step out. Alrighty, so now we need to do here extends promise like of unknown. And then we can just run this here again. Promise like of unknown val or never. Okay, I broke it again. My weighted val extends promise like unknown never. Yeah, that doesn't make sense. I mean, you can also put anything in here. T extends null or undefined T. Special case for null undefined. T extends object. Recursively unwrap the value. You can run awaited on a number. It's so stupid, this extra error. Type test2 equals awaited number. Okay, I would say let's go through it again. So this is by far the nicest solution that ticks all boxes except this unreasonable error condition. I would suggest we do that, but we have to look into it again. So how do we throw here an error? Okay, I mean, the idea that I have now is that we extend here, extends promise like unknown, and then check here before we call that again. Val extends that actually the inner value is also a promise. Val extends promise like unknown. If that is true, we call it, here's the question mark. If that's false, we return t, otherwise never, and everything is broken again. No, we return val. T does not satisfy the constraint promise like unknown. Now the types are here not correct, honestly. I would say that's it for today. We take a look here tomorrow, and we're gonna patch this. Promise like info you might await it too. I honestly think we should get rid of this. Alrighty, that's it for tonight.